Hello, Science Alliance. Hello. So you can tell I've had a llama costume on, can't you? Hello, my name is Lara. It's IGCSE Physics. You're probably not new, but you might be new. I always say that you can just jump into any of my free live stream lessons for home educators anytime. The IGCSE one is the one where that's the hardest to do because obviously this is lesson 11 of electricity and I can't recap the whole of electricity. So if you are new, absolutely feel free to keep watching. It's brilliant and I will try and help you out as best I can. But if you find it difficult, don't worry about it. That's just because we're sort of nearly at the end of the course. After Easter, so next week we've got one more electricity lesson left. Then 2 weeks of Easter holiday, and then after that we're starting waves. And we'll all be on the same page. That is an excellent time to start. Okay, but today we're going to learn about power. Can you get a couple of cans of food if you have a couple of cans of food in your house? Just going to do a little bit of exercise. Uncross your legs if your legs are crossed. Just loosen up your shoulders a little bit. Let's just lift these cans of food up into the air and down again 5 times. I'm not a PE teacher. It's harder than it sounds leading people through activities. Well, let's have a go. So hold the cans. I don't know, how do you hold weights? Like that? Make your arms into an L shape. Lift the cans towards the sky and back down again. We're going to do this. Let's do it 10 times. I only did it 5 times on YouTube. We'll do it 10 times. You ready? And go. 1. And down. And 2. And down. Can you feel your shoulder blades really connecting? That's 3. And keep your back nice and straight. That's 4. That's right. And then 5. Keep your core connected. 6. Make sure your shoulders are nice and relaxed. Yeah. 7, there we go, down the same bit again, just 3 more, come on guys, we can do this, come on, that's 8, is it? And another one, shoulder blades back, that's it, and 9, and 1 more, deep breath in, and that's 10, well done. Right, now let's do that again, but much faster, you ready? 3, 2, 1, go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which one's more tiring? That's the second one, isn't it? Hopefully. I mean, the point of this lesson is that the second one should be more tiring, partly for biology reasons, which I don't care about, and partly for physics reasons, which we're going to learn about now, because the difference was something to do with time, wasn't it? When you push up on a can, you've got the force of gravity pushing back down, the weight of the can being pulled to the ground, and you're pushing against that, so you're shifting energy, right? We get to learn all about energy later on, but what you're doing is you're giving the can gravitational potential energy, but the amount of time it takes for you to do that makes a difference to how tired you are. And we've been talking a lot about energy, but we haven't related that to time. So we're going to do that now. I've got a little recap for you. You should really, if you've been to all the lessons so far, you should be all right with this. If you're new, you've got a great excuse for not knowing this, and I'll just talk you through it in a sec. But here we go. I've got 3 equations here for current and voltage and for power. And I want you to fill in the gaps. I've put in loads of gaps and I'll take a couple away in a sec, but I wanted to make it harder first so that you can sort of work your brain, and then I'll give you some clues. So current equals charge, which is measured in coulombs, divided by something. But what is it? So the units of current are coulombs per something, but what? And when you're talking about current flowing, like charge flowing through a wire, you don't say the current is 5 coulombs per something, do you? You give it a proper name. So what's the kind of cool nickname for coulombs per something? See what I mean? Voltage, what's the equation for voltage? It's something per something, something divided by something, but we don't know what. And I haven't told you what the units are, and I haven't told you what the cool nickname for the units are either. I mean, the actual unit. We'll get to this. Power, I haven't told you anything about the equation for power, but I have told you that the units for power are joules per second, and the cool nickname, the actual unit of power, is the watt. But that means joules per second, okay? Capital W. Okay, so I'll give you a couple of, literally just a few seconds of that, and then I'll reveal a few so that you've got a vague idea of if you're going in the right direction. How hard you find this very much depends as well on whether, hello Aris, just checking my comments. Hey, Bastian's here, all right, and Monkey. Yeah, How well you do it, this depends on, I guess, whether you're actually thinking that you might do a physics GCSE and how much reading you're doing in the background. Okay, so the units of current are coulombs per second. That's a massive clue for you. And voltage is something divided by charge. Voltage is something per charge. What is it per charge? And I'll reveal one more. The units of voltage are, well, they're made up anyway of joules per coulomb. But you don't say the voltage was 5 joules per coulomb. You say something else. What do you say? All right, happy always. That's nice. Oh, loads of planets. I'm quite liking having the comments on YouTube. Happy, you've started a craze. Monkey is sending me a load of... Oh, it's a cat in a box. All right, here we go. Current is charge divided by time. Now, you should have got that, because do you remember, it's really nice. The units just tell you what the equation is, because whatever you do to the qualities, like if current is charge divided by time, the units of current are the units of charge divided by the units of time. It says it right there, look, it's a little dividing sign. So charge divided by time gives us current, and the units of current are basically coulombs divided by seconds. But you don't say coulombs per second, do you? You say amps. So for goodness sake, if you're doing this in an exam, write amp. The amp is the unit of current, but I think it's very useful for you to know where that comes from. Volt is energy per charge. Did you get that? So energy is measured in joules, so the units of voltage are joules per coulomb, the amount of energy per charge. But again, we say the volt, right, with a capital V. And power, well, if the units of power are the joules per second, which is the watt, you would say the watt, then power must be whatever joules are divided by whatever seconds are. So it is, it's energy divided by time. So power is energy per time, the amount of joules per second that something shifts, if you like. We'll come back to how you rearrange that equation in a little bit. Okay, I think that's basically all I need to tell you. Did you bring along a piece of electronic equipment that is unplugged so that you can have a look at the... I mean, actually, mine isn't on the plug. I've got these hair curlers, tongs, which you can tell I don't use very often, from the 1990s or something. But if you have a look on the side of it, you should find it has a power rating. Your appliances in your home will have a power rating. Here, come here with me. Flip them around. So next week is our last electricity lesson, and we're talking about household electricity. So we'll find out then why you're... That's nice, someone saying they like physics in the comments. We'll find out why you've probably got something like 230 volts written there. And we'll find out why you've got something like 50 HZ written there. But today we're looking at this one. Can you see that says 50, the capital W? That means 50 watts. So these tongs have got a power rating of 50 watts. So they shift 50 joules of energy per second. Right, that's all you need to know. I'm going to give you this little question sheet. We've got some animal chums here. I've made this question more complicated than it needs to be. The situation is, there's some animal chums and they're rebuilding their houses, apparently, and they're having a competition to see who can dismantle their old house the fastest. Calculate how powerful their chainsaws are to work out who will win the contest. Just calculate how powerful the chainsaws are, okay? Do that. So Squirrel's got a chainsaw that transfers 200 joules of energy in 30 seconds. I'm giving you this equation, power equals energy divided by time, right? Joules per second, the watt. Hedgehog's chainsaw uses 750 joules in 2 minutes. Rabbit's chainsaw has a power rating of 1 kilowatt and she uses it for 1.5 minutes. Chick's chainsaw uses 100 joules of energy in 15 seconds. In 1 minute, Penguin's machine, chainsaw, transfers twice the amount of energy that Squirrel's does overall. So get the answer for Squirrel's question. Penguin's machine transfers twice that amount of energy in 1 minute, in twice the amount of time. Okay, so have a go at those. Jacob, very scientifically, in this Facebook lesson yesterday, when I taught this yesterday, said, so are all their houses exactly the same size? So well done if you thought, but yeah, of course, that's what they would have to be to make it fair. And it is, in fact, true, yes, they all live on the same 1990s cul-de-sac, so they are all the same. I did say to bring a calculator. I wouldn't expect you to do these without a calculator, and you obviously will have a calculator in your exams because calculators exist in life, so it doesn't make sense to test how people work when they don't have them. How are you doing? There may or may not be a trick question in there. Not a trick question, that's a bit harsh. But I maybe been a little bit mean. Give you like a couple more seconds. All right, should we go through it? I'll leave all the questions up anyway, so while you're ticking off the ones you've done before, you can sort of carry on working on your later ones. So the first one isn't a trick question, is it? Squirrel's got a chainsaw which transfers 200 joules of energy in 30 seconds. So power is energy divided by time. So it's 200 divided by 30, which is 6.7 watts. I hope I haven't confused you. If you've written 6.7 joules per second, that's great, that's fine, but make sure that you then write equals 6.7 watts, because watts is measured in, is the unit of the power, yes. That would be a great way of just making sure that you had the right answer, but make sure that you end up saying that it's watts. Okay, hedgehogs uses 750 joules in 2 minutes. Did you make sure, right, the unit of power is made up of joules per second, yeah? The watt is joules per second, so you can't just do 750 divided by 2 minutes. You're okay with that, aren't you? Or you get an answer which was joules per minute. So you've got to change that 2 minutes into 120 seconds and then do the sum from there. So hedgehog's power rating is 6.25. Oh, squirrel in the lead. This one was a bit mean. Rabbits has got a power rating of 1 kilowatt. Well, what is 1 kilowatt? It's a unit of power, right? So a kilogram is 100 grams. And a kilowatt is, a kilogram is 1,000 grams, and a kilowatt is just 1,000 watts. So that is the power rating. If you got asked, like, how much energy does Rabbit's chainsaw shift, then you could rearrange the 1,000 watts and the 1.5 minutes and convert them and get the answer for energy. But you actually already had the power rating there. Chicks uses 100 joules of energy in 15 seconds. That's right, isn't it? You've got energy in joules, you've got time in seconds, so just divide them by them and you get 6.7 watts. Ooh, tying with Rabbit. And Penguin's machine, oh no, sorry, tying with Squirrel. Penguin's machine transfers twice the amount of energy that Squirrel's does overall in 1 minute. So it's power equals energy divided by time, which is 400 joules, because it transferred twice the amount of energy in 1 minute, which was 60 seconds, so it's just the same answer. Is that okay? Transferring 200 joules in 30 seconds is something just as powerful as something that transfers 400 joules in 1 minute. It's the same. So well done, Rabbit. You win. And well done if you spotted that slightly mean question. You got that? So 6.7 watts, 6.25 watts, 1,000 watts, 6.7 watts and 6.7 watts. And Rabbit is the winner. Okay, I'm moving on. Right, so we need to do, whoops, sorry, that was my Lego phone holder going for Burton. We need to have a little maths interval here, because I want to look at how you rearrange these equations. There's a really simple equation for power that you need to know. But how it crops up using equations that we've looked at already is quite nice. this, I think. I like it. I like this. So let's have a little play with this equation, okay? I'm going to write this on the board as well so I can show you what I would do. 8 divided by 4 times 4 divided by 2. Some of you will just know this already, you're all in different places with your maths, but you know, we can't assume that everyone knows stuff, can we? So we're just going to quickly go back to the beginning for the people who aren't sure. So let's have a little play with this equation and see what happens. So you've got the sum 8 divided by 4 times 4 divided by 2. What is it? Well, you can probably work it out, can't you? Because you probably know that 8 divided by 4, 8 shared out among 4 people is 2. And 4 divided by 2, 4 shared out among 2 is 2. So it's 2 times 2, which is 4. So you probably know that the answer is 4. But what you could do is you could sort of extend this line across like that and do the top ones times the bottom ones, and you get the same answer. So 8 divided by 4 times 4 divided by 2 is the same as 8 times 4 divided by 4 times 2. It is. Look, I've just extended that line across and put the times on the top and the bottom instead of in the middle. Yeah? Shall we see if does that still work? So 8 times 4 is, what is it? 8, 16, 32. Divided by 4 times 2, which is 8. What's 32 divided by 8? Oh, gasp! It's 4. Beautiful maths. There you go. Should we do one more? Just to check that you're okay with that. If you're totally fine with this, then I'm giving you massive clues as to how you combine the equation for current and the equation for voltage and get an equation for power. Let's do one more. Let's do 10 divided by 5 times 5 divided by 2. So what are we going to do? We could draw that line right across and do 10 times 5 divided by 5 times 2, which is, what's that? 50 divided by 2. Oh no! I know what I wanted to tell you. Yeah, the whole point of us doing this, blooming it. There's another step you can do, which is even better. So you could do this and work it out, but you've got a 5 on the top and a 5 on the bottom. You times it by 5 on the top and you times it by 5 on the bottom. You don't have to do that. They just cancel out. If you've got something on the top and the bottom, they cancel out. So we can get rid of that 5 and get rid of that 5. They've cancelled. So now we're just left with 10 divided by 2, which is 5. There we go. And does that work out? Well, 10 divided by 5 is 2. And 5 divided by 2 is 2.5. And 2 times 2.5 is 5. Yeah, it did work out. Okay, good. Whew. Right, so hopefully you're okay with that. If it's the same thing on the top and the bottom, you can cancel it out. Okay, fine. Now I get to show you this, how to squidge current and voltage equations together to get an equation for power. Here we go. So, current is charge divided by time, yeah? Voltage is energy per charge, energy divided by charge. Lovely, lovely. So let's put those together. Times them together. Let's do charge divided by time times energy divided by charge. Okay? What are you seeing? What can you see straight away? Well, we extend that line across like we did before. So charge times energy divided by time times charge is the same. You all right with those two are the same now? It's just like the little examples that we did earlier. So we've just turned that into that. And now look, we've got something on the top and something on the bottom. So we can cancel it out, just like we just did. We can get rid of those charges. So what we've done is we've taken the equation for current and the equation for voltage, and we've times them together. And we've ended up with just energy divided by time. omg.com/wow. Energy divided by time, what is that? It's power, isn't it? So energy divided by time and charge divided by time times energy divided by charge, they're the same thing, yeah? We just put them together and cancelled them out. So energy per second, energy divided by time and current times voltage are the same. And what are they? Power. Yay! We got there. You don't really have to understand that if you haven't followed. That's totally fine. But I think it helps to know where that comes from. In your exam, you just really need to know that this is the equation for power, I think. So power is energy divided by time, but power is also current times voltage, okay? So you can write that out as this. P equals IV. Power equals current times voltage. I it represents current because physics hates you. So have a go at these. The chums are lighting their new homes and they've got some questions. Can you answer them using power equals current times voltage? Squirrel's filament bulb filament bulb. Squirrel, get with the program, dude. Squirrel's filament bulb operates at a voltage of 230 volts and has 0.5 amps running through it. What is its power rating, please? Penguin's bulb operates at 12 volts and has 2 amps flowing through it. How much energy does it use per second? Chick's head torch, bless you, Chick. Chick's head torch, with a power rating of 58 watts, has 2.9 amps flowing through it. What voltage does it operate at? Hedgehog's torch has a power rating of 5 watts and a voltage of 10 volts. How much current will flow through it? And if you've done that, it's possibly slightly easier than the last one, can you put voltage, current, energy, and time into an equation? All of them together. Oh, I should say, if you're new, well, actually, you can comment on this video, can't you now? So most people just do that now. But whenever I'm live on YouTube, I always put a post up on my Facebook page, at the top of my Facebook page, saying that I'm live on YouTube, and you can comment on that if you like. Did you all see that I got hacked on Facebook? My Facebook account, with 44,000 followers, is no longer in my control, nor is my old Facebook group, nor my old Facebook messages. So I've got a brand new Facebook group and Facebook page, which I've linked to. If you go to my YouTube homepage, then I've linked to them there. You can get to them. There's like a little video going, I got hacked, in red. So yeah, follow that. You get to the new Facebook page and you can comment on my new Facebook page if you like. The algorithm needs all the help it can get, frankly, because unfortunately if you go to Facebook and just search theatre science, you still get my old page, which is now just, I don't know, some videos of women that aren't me. Blooming women who aren't me. Get in the bin. I've just been ranting and completely lost track of time. I think I'll just be silent for a couple of minutes so I can get these questions done. Have you done? Should we go through it? I'll do what I did before. I'll leave the questions on the board so you can be finishing off, but I'll go through it. So Squirrel's filament bulb operates at a voltage of 230 volts and has 0.5 amps running through it. What is its power rating? Well, power is current times voltage. There's no tricks there, are there? There's no like megavolts or micro amps or anything like that. So it's just 0.5 amps times 230 volts, which is 115 watts. Splendid. All right, Penguin's bulb operates at 12 volts and has 2 amps flowing through it. How much energy does it use per second? I didn't catch you out there, did I? I was trying to stretch your brains. How much energy it uses per second is its power rating. Yeah, and that's how powerful it is how much energy it uses per second. That's what power is. So it's still just power equals current times voltage, which is 2 amps times 12 volts, which is 24 watts. Chick's head torch has a power rating of 58 watts. Ooh, equation rearranging must happen. It's got 2.9 amps flowing through it. What voltage does it operate at? So you needed to do voltage is power divided by current, which is 58 watts divided by 2.9 amps, which is 20 volts. And finally, Hedgehog's torch has a power rating of 5 watts at a voltage of 10 volts. What current flows through it? So again, you just have to do a bit of rearranging. Current equals power divided by voltage, which is 5 watts divided by 10 volts, which is 0.5 amps. Yay! Did you manage to put voltage, current, energy and time into an equation? Hopefully that's reasonably It's just certainly more straightforward than the last one. You got those answers: 115 watts, 24 watts, 20 volts, and 0.5 amps. All right, moving on. This is going to stay on Facebook, like YouTube, until the end of time, until the final days of civilization. So you can always come back to it if you need to. Okay, energy equals power equals energy divided by time. We know this. Power equals current times voltage. We also know this. Look. What do equal signs mean? They just mean it's all the same. So power equals energy divided by time equals current times voltage. They're the same thing. So we can go, all right, well, in that case, energy divided by time must equal current times voltage. And it does. So there you go. We've already got it. Except it's not very nice having this time being divided on this side. So we've looked at a lot before. You need to rearrange equations for IGCSE physics. We'll just take this time which has been divided by that side and we'll move over to that side so it's been times. So you end up with that. Energy equals current times voltage times time, which, like I say, because physics, it just hates you and it doesn't care about your exams, you write it as E equals I for current, V for voltage, and a little t for time. There. Right. So, one quick task for the people who've been watching. If you haven't been watching, you've got a great excuse for not being able to do this, but unless this is your very first lesson, can you please sketch a circuit that could measure the power rating of a bulb? Can you sketch a circuit that could measure the power of a bulb? I'm doing it too. I'm doing it right now, right behind you, she says smugly. We're all in this together, except, yeah, I've got a science degree and I've been a physics teacher for years, so not really the same as it, but anyway. I am doing it with you. It's just, you've got to remember some circuit symbols, haven't you? And how they all go together. Oh, it'll be good practice for you. Maybe it was a bit kind saying a bulb. Maybe I should have said for a diode. Yes, I should have said for a diode, actually. Go on, stretch yourselves. Do a diode as well. Sketch a circuit that could measure the power of a bulb and sketch a circuit that could measure the power of a diode. Go on. Unless you're brand new, do it. Do it. Have you done it? I was a bit mean, wasn't I? I didn't put any of the equations on the board. What do you need? You want to measure the power of a bulb. What do you need to know if you want to know how much energy that bulb is shifting per second? What do you need? Do you need a stopwatch? Do you need a battery? Do you need a little special microscope so you can watch the charges going? I don't know where I'm going with this. Shall I show you mine? Because you've probably done it by now, or you just sat there going, I don't know, just tell me. No! Science, pixelated. It is your first lesson. That's amazing. Science pixelated. Tell me in the comments it's the first lesson. That is so cool. I can't believe you've sat through all this nonsense and it's your very first lesson. That is awesome. Wow. You must be really good at just taking in information without going, I don't know. I'd be crying. Anyway, it's great. I'm assuming that you're not crying. Let's go through the answer then for you. Well, what you need to know is you need to know the current going through the bulb and you need to know the voltage across the bulb, okay? Because we've seen that power equals current times voltage. No, the same! No, we've got loads of new peeps here! My voice has gone squeaky and excited. Yeah, power equals current times voltage. So if you know the current flowing through the bulb and you know the voltage across the bulb, you know it's power, right? So this is how you build a circuit anyway. To measure the current flowing through something, you need something called an ammeter. Yeah, ammeter, because amps, because that's what you measure current in. So that ammeter measures the current flowing through it, which is also the current flowing through the bulb, like that. If you're enjoying these, you can go back. They're all saved on my website. And this voltmeter measures the volts of the bulb, the voltage of the bulb, across like that. And that's the circuit symbol for a bulb. And this is the circuit symbol for a battery. Folks who've watched before, when I did this on Facebook yesterday, I put in a variable resistor thinking, oh yeah, you need to be able to change the voltage and change the current and get a table. But you don't really have to, do you? I mean, you could do, I suppose. It'll make your results more reliable, but you'd have a good idea without that. Did you do the diode one? Because, who was it? Was it Amelia? Pointed out last week that I'd drawn my diode wrong. When you're drawing a diode is something that only allows current to flow in one direction. The line goes all the way through the triangle. I blanked out and started doing the triangle as empty, but it's not. So that would have been a diode. Is that going in the right direction? Current flows, convention is from positive to negative. No, it's not, is it? Current is flowing in this direction from positive, the long line, to negative, the short line. I'm just going to be lazy and change it like that. There, fixed it. 1 positive, 2 negative, and I'm going to put a tiny little resistor in as well, so that this diode doesn't melt. Brilliant, right, phew, well done. Okay, you lot, that's nearly the end of the lesson, except if you are actually wanting to do IGCSE physics, then there's 2 different exam boards that could write your exam. There's Pearson and there's Cambridge. They pretty much want you to know the same stuff, but if you're revising, you absolutely have to know which exam you're going to take. Is it the Pearson exam or is it the Cambridge exam? Because there are a couple of little differences. And one of the differences, these things called kilowatt hours. So as far as I must admit, I haven't double checked the Pearson spec, so you do. But as far as I can tell, Cambridge need you to know about kilowatt hours and Pearson don't. So let's very quickly talk about kilowatt hours. It's interesting actually. This is generally what people talk about in real life when they talk about electricity. What do you reckon a kilowatt hour is a unit of? A kilowatt hour, not kilowatts per hour. What's a kilowatt hour? Is it how you measure like distance, speed, power? What? You know how like distance, you traditionally measure it in meters, but you could measure it in inches or feet or furlongs. A kilowatt hour is just a different unit for something that we've mentioned, but what is it? And then I'll show you the BBC using it wrong. Kilowatt hour. It's not distance. Well, what is kilowatt a unit of? So a kilowatt is 1,000 watts. If I told you this thing's 1,000 watts, what would I be talking about? A speed, energy, power, distance, if it's 1,000 watts. And what's hour a measure of? And then that line means that you're timesing them together. If it was kilowatts per hour, it would be something divided by something, but this is just something times something. Well, you've got your power equation here. So kilowatts is a measure of power, yeah? Kilowatts just means 1,000 watts, which is the unit of power. Hour is obviously a measure of time, so you're doing power times time. Oh, look, energy equals power times time. So the kilowatt hour, deeply confusingly, is actually a measure of energy. So huge buzz, deep excitement in my little northern city, it is a city, of England, of York, when the York Minster announced that they were going to put some solar panels on top of the roof. I know! What would God say? Well, it's okay, folks, it's happened. But here's the story from March 2023, saying that it was going to happen. York Minster are going to put solar panels on top of its roof. Look how beautiful. Thanks, BBC, for this very good example of how not to do it. So they say solar panels are to be fitted to the roof of York Minster in a bid to tackle rising energy bill, blah, 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 blah. The panels are expected to generate 75,000 kilowatt hours, right? Little k, big W for watts, small h for hours. 75,000 kilowatt hours of power a year. What's wrong with that? Kilowatt hours of power? Kilowatt hours of power, BBC? Kilowatt hours of power? No! It would just, power is measured in watts, isn't it? It could be kilowatts of power, but not kilowatt hours of power. That's not right. Well, I'm pleased to report that later on, the Minster on their website fixed the problem. Here you go. Good old Minster. So they had a blessing. They've got solar panels on the roof, which is a really nice idea because the York Minster roof is absolutely massive. So now it's they've really cut their bills. I don't know why this number changed. Presumably this is more realistic. But yeah, the panels will generate an estimated 70,000 kilowatt hours of energy per year. Yay! Some nerd like us has contacted them, said, "Oh, excuse me, I think you'll find." Brilliant. So there you go. That's a good example of people in real life, even journalists, getting it horribly wrong. I'm going to give you a couple of very, very simple questions. So again, if you're new, I've been a bit tardy this week because of my Facebook page being hacked, so I haven't put the homework up. But usually, if you go to my website, then I put up a homework PDF just for my IGCSE physicists with some links to some websites that you can read, usually the website that I've read as well, or some videos that you can watch, or some past paper questions that you can do to really get it into your head. And kilowatt hours is one of those things where you're better off reading about it, because you probably need to read like 8 different descriptions of it before you find one that makes your brain go, ah, yeah, okay, great. But here are some really simple questions for you to just mull over. My brain, some of you will be able to just see these answers straight away, and some of you will need to stare in silence at the screen for a bit, so I am going to be quiet now. I want you to imagine, this is a bit high actually in the UK, but let's say energy costs are about 40p per kilowatt hour, okay? 40p per kilowatt hour, that's how much energy costs. If a hairdryer has a 1 kilowatt rating, how much does it cost to use it for 15 minutes? A hairdryer has a 1 kilowatt rating, how much does it cost to use it for 15 minutes? If you're not getting it, think about it like this. If you run a 1 kilowatt thing for 1 hour, that costs 40p. All right? If you run a 1 kilowatt thing in your house for 1 hour, that's going to cost you 40p. So a hairdryer has a 1 kilowatt rating. How much does it cost to use it for 15 minutes? And a TV has a 0.25 kilowatt rating. How much does it cost to watch 2 hours of TV? So it's up to you. You might have answered them both while I was talking, or you might still be staring at question 1, but that's fine. As long as you're staring at it and you're fusing some neurons, then I'll explain it in a sec. Loving these comments, by the way. I'm not always mentioning them because it might be a bit distracting for people watching, but I am really enjoying seeing the comments flicking by. You're going to make a YouTube sort about definition of kilowatt hour. Link me to that, won't you? Definitely link me to that. Oh, you guys. Do you like how I said link me to that, as if I sort of knew how to do that? Not very good on YouTube. Have you got it? So it costs 40p to run a 1 kilowatt thing for 1 hour. So if the hairdryer's got a 1 kilowatt rating, if you use it for an hour, it would cost you 40p, but you're only using it for 15 minutes, so a quarter of an hour, so you're just spending a quarter of the money, so it's 10p. Is that right? And the TV, have you done that one? How I have to do it is, okay, the TV has a 0.25 kilowatt rating, so that's a quarter of a kilowatt. So if I ran my TV, which is a quarter of a kilowatt, for 1 hour, it would cost me a 10p, right? It would cost me a quarter, wouldn't it? Is that okay? Costs 40p to run a 1 kilowatt thing for an hour, so to run a quarter of a kilowatt thing for an hour would cost me 10p, but I've watched it for 2 hours, so it would cost me 20p. That's what's going on in my brain when I read those questions. I've got to take those really slowly. It's not a bad idea if you're in an IGCSE physics exam to slow down. Okay, and that's as deep as we will go into kilowatt hours. And like I say, I will put together some homework for you this week and put it up to my website. So if you keep checking my website, eventually I will have updated that and you will be able to do the questions. Okay, you lot. All right, so how it works is, for the new people, so cool that you're new. Can't wait for us all to start waves now, because at the moment we're a mixture of people who've been watching for 12 weeks and people who've been watching for like 35 minutes. But yeah, 1 more week of electricity. We're doing like AC and DC and how not to get electrocuted next week. And then I've got 2 weeks off for Easter, and then we're going to start on waves, sound and electromagnetic waves. It's going to be great. So how this works is, this is actually my job. This is my full-time job. I know, it's so good. How it works is, I'm trained to teach physics up to A-level, but I was also a sort of actor in a past life, and I just stream everything for free. So I stream this thing called a Lego story show, which is where I just chat about something and we do a science activity, and then there's a little story told with Lego at the end. And I do this all ages lesson, which is kind of my bread and butter that most people come to, where it's a bit like this, but it's not teaching to a specification, like there's no exam at the end, so we're just learning just any kind of science really, with activities and questions and yeah, all that stuff. And yeah, I just say, if you can afford to send me £5 a month, can you send me £5 a month? And that is enough to keep me going, and I will even send you very nice things to say thank you. So if you signed up to support me on Coffee, if you go to my About section, I still don't know where it is, but somewhere on YouTube at the top, go up to the top Oh, yeah. Oh, I see. You've got the magazine. Oh, so you've seen me before. You just haven't seen GCSE. I see. If you go up to the top of my YouTube channel and you go to the About tab, it gets you to this website called Coffee anyway. You can send me £5 a month and I'll send you some nice things to say thank you so much. It's the best job ever. I'll send you some rainbow glasses. They're actually diffraction glasses. We'll learn about them when we do waves. And I'll send you the Science magazine. There's another one due out. I mean, God, it was due out literally about 8 months ago, but it's coming out very soon. But if you sign up now, I'll send you some past issues of the magazine that I write. Oh, your sister did the Roman ones. Oh, I see. Ah, it's quite cool on YouTube. It's all like a bit mysterious because on Facebook I know who everybody is, but I don't know who you are. But I don't hate that. Yeah. If you sign up with £5 a month, I'll send you the mould issue. It's got a home compostable plastic bag that comes with it, so you can actually grow some mould and identify it. It's got a beautiful comic about how penicillin was discovered. It's got Choose Your Own Adventure. I pour my heart and soul into the Science magazine. And if you sign up with £6 a month, I'll send you. Oh, thank you. Yeah, send me the link. If you sign up with £6 a month, I will send you the sleep issue, which also has a Choose Your Own Adventure and comes with some organic lavender and some material so you can do a little bit of sewing. It's got an origami koala in it because they sleep the most. It's got a load of stuff about how your brain works when you're sleeping. And if you've already got those because you're supporting me, you are automatically on the list to get the next magazine, which is about spies. We're going to do, there's a big long story about Mary, Queen of Scots, and how and you've got to sort of spot how she's going to end up. And there's a paper folding activity where you can melt some wax. I'm going to send you a very good quality little wax cube that you can make a little stamper with, like how they used to seal envelopes in ye olden times. I'm very excited about it. There's a James Bond jigsaw. There's all kinds of stuff. I'm very excited about it going to the printers and then coming back from the printers and then getting out of my life and into your life. This is what I'm deeply, deeply excited about. Right. I'm going over to my Facebook page just to see if anyone has left me any hellos. There's quite a big ask. Oh, there's some comments. Oh, not only did you bother to go to my Facebook page and leave me a comment, you bothered to come to the right Facebook page. Oh, Jacob's here. Yeah, and Edmund. Oh, Edmund is wondering if this E equals IVT means that IVT equals MC squared. Oh. As he already knows that E equals MC squared. Oh yeah, that's brilliant. And hello, Jacob. All right, E equals. So this is quite right because yeah, I mean, energy is energy, isn't it? So Edmund knows that E equals MC squared, and also we've just learned that E equals capital I, capital V, little t. So does that mean IVT equals MC squared? Now let's see. I mean, I'm trying to think, like, because you know how you can have, like, I mean, I suppose the honest answer is that I don't know, Edmund, really. I'm trying to think of a scenario where those two things would go together. What I'm thinking is, you know how, like, the area of a square is its base times its height, right? So you would say area in that case equals base times height. But the area of a circle is pi r squared, yeah? So what's the new Facebook page? It's Official Theatre of Science. So it's facebook.com/official theatre of science for I am the official one. I don't know what I'm going to do if I get hacked again, but let's hope that doesn't happen. So that's the area of a square and that's an area of a circle, and obviously they both say A, but you wouldn't say that the base times the height of a square is pi r squared. And I'm trying to think in my head whether this is that scenario, or because like the energy, the sort of energy of a particle is its mass times the speed of light squared, and the energy like shifted by a bulb is current to that. I don't know. It's an excellent question. I'm gonna have to read about it. Sorry, it wasn't very helpful, was it? But it's a great question. It's one of those questions that I wish I hadn't read out loud, because now I've read it out loud, I've got to deal with it. All right, well, I'm gonna go. And I am going to go and read about some physics and hopefully get your homework up quite soon. I'll start planning next week's lesson. Like I say, 1 week left and then 2 weeks and then we start waves. Thank you so much for joining me. Thank you so much for all your support. I've wiped the link to coffee now off the board, but if you go to my About section and you want to send me £5 a month for all this work so that you can get diffraction classes and a magazine and a sense of absolute fulfillment because you have all my gratitude because this is the best job ever, then that would be great. Thank you very much. I will see you all next week. Bye.